Wow. Yeah, so let me pick up this question. So we're talking about the order of the inputs, right?
Yeah.
And then why does it matter?
Yeah.
It matters because what we're going to output, what we're going to compute out of this, right? Now suppose I submit my number, CC submit his number, and then we compute immediately, right? Without waiting for another one. Then this function, the output, maybe like it is a trivial function that looking at the output, we can revert CC's input or my input. So that is going to be problematic in that case of the order. Or if we think about like computing the order book just from several orders, right? It can also be problematic because I may not know exactly what is your price, but I can know the range and then I can play the game on you. So in general, we have to define like what is the linkage that you can accept. For example, we may want to wait for 1,000 orders, or we may want to receive the inputs from everybody, like in the auction case where everybody input the bid before we actually do the computation. Or we have to make sure that if we are using FHE, that is computed on all of these inputs, right? Because looking at the ciphertext, you don't know what is the function behind it. So we may want some verifiability out of the computation.
So is that because there's basically a side effect happening on some external state?
Yes, exactly.
And we have to just like anonymize the input at that point. But like in the FHE context, so I guess that's for a very specific type of context where we have in the clear, publicly advertised like output.
Yeah, because like the problem with MPC is that like if you compute a trivial function, just an addition over two number and then looking at the result, I have my input, I can just do a subtraction, right? It is pointless.
Yeah.
Another problem is that like what if I input garbage value? So I'm not being honest here. So it's like the interface of the MPC is like that. There is nothing you can change about it. So you have to augment it with something else. For example, inside the MPC, you may want to do some sanity check. For example, if you want just positive integer, you have to check it inside the MPC. Or you have to prove that the input you send into this MPC or send into FHE satisfies some requirement before we actually do the computation. So like those are like subtlety. But, well, like it's subtle, right? But fortunately, we can think of it from the application point of view. We don't have to like know the crypto to be able to do it. So it's all from the application perspective.
So it does make sense to, when building this application, it does make sense to reason about what the circuit is doing, so that you avoid the trivial cases of privacy leakage like addition and stuff. But yeah, I think it is like I think it's the responsibility of the application developer to reason through all these trivial complexities, just to make sure that, let's say if you and I are adding numbers, then obviously, and if we decrypt the output, then we would learn each of the numbers, right? So such trivial cases cannot be handled automatically because there are too many of them. But yeah, if you are able to figure out these, if the developer is able to reason through these things, then other cases can be handled automatically in FHE. It is, sorry.
I mean, in your language, is this kind of like batching thing, is that considered synchronous in that context? Because it's almost like a window.
I mean, what Nam explained sounds a little bit like an anonymity set in some typical, like even in CK applications today, we have this kind of term, right? When we're like accumulating something and then it's impossible to figure out who is who. But as I understand now, it's more like an application-specific thing. So if in this particular application there is the vulnerability, you need to have that anonymity set. But if there is no such problem, then you can maybe like do one by one. Like typical FHE example that I hear is like hospitals sharing medical data, right? And like training machine learning model on the data. I guess in this example, the order doesn't really matter, and you can do it like in any order and output output some result after every step, because like you're not losing, you're not exposing any like private data or anything.
Yeah, a very simple example you could take is that, let's say you and I have a contract and we want to check whether our contract terms match. We just check it one more, there's no leakage. That's it. So a very simple example, you don't have to batch anything or something like that. I would rather, I wouldn't take machine learning training as an example for FHE especially, honestly, because when you train, I mean, you can do machine learning training with FHE, yes, that's okay, but when you train a model, there are attacks on the model that leaks the input. You can trick the model to output the training data. Then if that is possible, then doing it in encrypted form does not make that much sense. Instead, you should try adding noise to the input data, like DP, like differential privacy, to be able to make sure that no one can adversely attack the model to get the private inputs. Does that make sense?
Can we attach a zero knowledge proof and send that to the FHE model that this does not contain any adversarial attacks while training?
No, adversarial attacks after training. So let's say you and I, like all of us, have a private inputs and we train the model together. We have private inputs. Let's just say there's a very expensive computer out there and we are training a model. Now once we have that model, people will use it, right? Now there are adversarial attacks against the model to output the private inputs, because the model has been trained on a private information. Right, so if I run inference on it, there's a certain set of inputs that I can feed to the model such that it outputs the private training data. Does it make sense? And if such attacks are possible, then private training does not make sense. It only, like, you will have to add certain noise to your private inputs itself, and the noise it's a concept from differential privacy. Like, even if you're able to output the private inputs, it would have noise such that you cannot uncover users. And
so just on that note, so let's say that we jointly trained with their private inputs and someone's trying to attach this model to feeding in specific inputs to derive a private. Does the fact that it's encrypted in any way make it harder, or is it the same?
It's the same.
Really? Okay.
It is, because the model is a model, right? It's the same information.
Right.
It remains the same.
Yeah, so I have a note on that. So, like, MPC, FHE, this is called privacy preserving techniques. Preserve privacy.
Yeah.
It doesn't generate privacy. So it can only as private as your original function, right? So if attacks on like blind model can be like done, then attack using the same way in MPC can be done. It's only as good as the original one. It cannot be better. It's lower.
Yeah.
But not good enough for us.
So for like each of these paradigms, right? Like, I don't know. There's reasons why like ZK has a very nice synergy with blockchain, right? Like the blockchain can act as a very simple verifier in that context. Like how do y'all see these interacting with blockchain contexts, or are these just kind of like extra protocol things independent of?
I rather see FHE and MPC as something that will allow us to see cryptography in the real world, like outside world, that is other than blockchains. It is not just limited to blockchains. I know people are trying to build FHE stuff with blockchains as well, but it's very hard to. It's very hard to have FHE and MPC in decentralized setting due to Leibniz assumption. Yeah.
But I think maybe my question will be like a very particular subset of your question. Like, there are certain architectural patterns in ZK that are partially enabled by blockchain. Like, for example, ZK itself, it's proving that there is an input that is satisfying the computational statement, but it doesn't prove that this is a real input, right? And for that, we are using certain architectural techniques. Like, we need to commit to something. We have like a cryptographic commitment that is public. Most of the times we put it on chain into a smart contract, and that's why ZK works very well with blockchain, because we put the public commitment on chain, and then we, when we're verifying zero knowledge proof, we know that those private inputs that went into the proof, they actually correspond to the public, let's say, public inputs or public outputs that were previously committed on chain. So are there like certain patterns in MPC, FHE that are similar to the situation with ZK? Like, what should we know about, like, if, for example, if I want to build my first MPC or FHE application, what architectural patterns I should know?
So maybe I can pick that up. So we are talking about like ZK integration with blockchain, right? You have a public commitment. You try to, like, this is commitment of some secret data that you own. So you want privacy using the ZK and blockchain, right? And then you try to update this secret value to a new value using some function, right? And then you commit it again. And so this commitment is now your new value. And you can actually prove it using ZK. Right? Nobody knows what is the old value, what is the new value. They only know that you have performed the eligible computation on it. And we should acknowledge this commitment from now on. But then think about it, right? What is the kind of application that you can build using this pattern? You can only update your own data. Right? Suppose I have some data, CC has some data, we want to compute using our data. Right? So that is where we can see the pattern arising. Using MPC, we can do some computation from our commitment. So you pull your commitment, I pull my commitment. We don't need to know like what is the secret value behind, because we just need to prove that, okay, it has to your commitment, my value has to my commitment. We do some computation, we output the result, and then like we can like commit to the new value from your on your side. I commit to the new value on my side. We can prove that there is an interaction between us using MPC, and then from now on, when we submit this back to the blockchain together with some ZK proof, we can make sure that, okay, we have manipulate our secret data together. And then these new values, these new commitments should be acknowledged because they are verifiable. So MPC, 2PC, or even FHE, you can do that to a certain extent. Certainly enable this like broader application on chain.
Yeah, I think I've heard like King Kong say something similar about this. Like if you want a fully private blockchain, you want to attach FHE to everything. For example, for a fully private blockchain, you want to send a value to someone, so you have unknown sender's balance, unknown receiver's balance, and unknown value sent. So you probably need you first need a ZK proof that your unknown value has enough balance to send, and then you have FHE, and then your like result is accepted correctly. So the sender value unknown, but updated to another unknown value, but it's updated correctly, but and everything stays in private, but like
yeah. So I think like there is this concept of FHE EVM that so you just encrypt your secret, right, and then put it on chain, and then these validators, they can run the function in clear for you, and then change your input to a new value using FHE, right? But then, so they have this. I joined the Discord channel and asked, hey, so it's good that you can do this, but what is the gas cost? They didn't answer.
A lot.
Huh?
A lot.
Yeah, it's going to be expensive.
Yeah, it is. It is.
But the current gas, like the gas cost is kind of, like specific target for the consumer grade computer. But with FHE, like you can do everything in a centralized party. You no longer need a peer network, right?
The problem with FPG in decentralized setting is the threshold assumption, moreover. Like, you've got multiple parties, you've got stakers. Let's just imagine that you've got stakers, right? Proof of stake. Each of them have secret shard for the distributed key generation. Now we cannot expect all the users of blockchain to stay to come online at the same time to perform this distributed key generation operation. So we want these nodes to be able to do that. Now these nodes can collude together to get the original secret. And that is problematic because we are in a decentralized setting. And that is the main bottleneck of adopting FHE EVM probably, because it's not as unless it is n out of n, unless it is multi-party, it is not as secure as ZK. It is possible for someone to just probably DOJ to just show up next day on a door, get all the stakers together and decrypt everything. So, and also FHE EVM, EVM model itself is now very old in the sense that it is also not very much suitable for ZK as well. So yeah, I think that it is very much possible. They're very unique applications that you can build with MPC and FHE that would seep into our real lives, like the applications that we daily use. That would have synergy with blockchains as well, but ZK would still be an important thing. FHE would still be an important thing, and MPC would still be an important thing. It's just that you cannot replace the privacy guarantees in decentralized that ZK gives you with FHE. FHE gives you a way to compute on encrypted data, but ZK gives you absolute privacy in this decentralized setting. It gives you an attestation of something that can be verified independently. And FHE works well with that. I can perform some computation with my friends and then decrypt it and produce a proof of decryption on chain, so that if someone else wants to build on top of it, they can do that. So here we combine FHE and ZK. But FHE in itself in decentralized setting does not make sense. ZK in itself for applications does not make sense. You need to combine these two things. And FHE EVM by itself, in decentralized setting, it's somewhat scary because of threshold assumptions.
Yeah, so in general, right? You want to build some application, you have decided what you want, what is the private features, then you move on to, okay, so which of these techniques that I'm going to use? There is no general answer, unfortunately, even for the cryptographers. So what we usually do for this is that we pick one and we try to improve it, right? So it's rather extreme. So it is going to be case by case. What to use depends on what you have at hand. If you have a small computer, you are far from each other, so you have to rely on bandwidth, then you can use Gabo server. If you have servers not so strong, but you can put them close to each other, right? Like university in this city, then you can use chicken chain, because round interaction and a moderate amount of bandwidth is not a problem for you. If you have big computer, and you have a lot of clients, then maybe you can use FHD, because like that remove a lot of hassle when you have this asymmetry between like you being a giant and then you try to interact with some app. Right? So it really depends on what you want to build and what you have in hand.
Yeah.
Is there any confusion about FHD or MPC? Because we don't know TK, we don't know their group, their form, computation development. So FHD and MPC has for the computation about base number or sign or unsigned integer.
I'm sorry, I didn't answer this.
So, the question is that is there any limitation about FHD or MPC? Because we know the real-time tools and the communication given. So, is there any limitation about the computation being FHD or MPC?
Yeah. So the question is that, like in ZK, it is very hard to work with real numbers because you work with unsigned integers and you have a bit field of 254 most of the time. Is there any similar limitation to FHE and MPC? I can describe you limitations and things that you can do with FHE. Probably now I can describe you the things that you can do with MPC. Does it work now?
Yeah, so like I think I can rephrase your question a little bit.
Okay.
Like so MPC eventually, or some people have tools, they are usually very expensive. Okay, so we want to leverage our application setting so that we can like be more efficient in using that tool. So in the case that you described, you have like arithmetic computation, right? And then you are saying that okay, it has to be in the field, but like being in that like is very efficient for the current data technology. There are different representations in using Gabo circuit, switch sharing base, or FHD. For example, in FHD you can have real number. In secret sharing base, you better have arithmetic representation. In Gabo circuit right now, I think it is most efficient for Boolean circuit.
So yeah, in FHE, there are several schemes. There's a scheme which allows you to work with real numbers, so you can have floating point operations, and that is known as CKS. There's another scheme called TFHE or FHEW that allows you to work with small plain text, like 4 bits, 5 bits of plain text, and allows you to perform very efficient binary operations like comparisons, maximum, minimum, and so on and so forth. The trade-off between these two schemes is that it is possible to have real numbers with TFHE and TFHE and FEW as well. But for that, you would have to need very efficient, like you would need hardware acceleration. In using CKCAS, you can work with real numbers on CPUs, but the problem with CKCAS is that it is not that much suitable if you want to have deterministic computation, like if you want to retrieve something from a database, or you want to perform some equality operations, because it works over real numbers, and with real numbers you already have errors because of floating point operations. So you have different schemes for different things. You can even switch from CKCAS to TFHE as per your convenience, but it depends on the application. But I believe that as we move forward with all these things, like as we have ASICs for FHE, this distinction between these two schemes would rather evaporate, like it would go away, And I believe that you can use view and binary schemes for most of the things because like ASICs are just too fast and they can perform floating point operations really fast. But don't like if it doesn't happen in 5 years, just don't come calling me back on this.
Yeah, if you guys think if it feels right for you to like move on to the next discussion, we can do that. But if it's still have things to discuss, let's continue.
We can talk about more things if you guys want.
So, do you think it's good to move on to the group discussion?
Yeah.
Yeah.
So I think like we have discussed a lot about MPC and FHE, right? But let's get back to the original goal. So we want you to think about application, the perspective of an application builders. You may try to think about what you are doing. If you are using ZK, you want to upgrade that to MPC, and what would be like the most interesting feature for you to work on. So that is the purpose of what we are moving forward. Maybe Mohan can introduce more in detail.
So I think later we will split into like how many people we have right now, like 20-ish. Yeah, maybe we can split into like four table right there. And luckily we have 4 PSE members here to help today. And maybe we can follow their view on how they decide how to incorporate MPC and FHE into their own project, and take that as a starting point to think about how to solve real world problem from that. So maybe we can have Kevin, Vivian, Alex, and CC have a quick introduction about yourself, like 1 minute. Yeah, and then we can split into 4 groups, and we just grab our seats and move into the table over there. Yeah, and each group is like 5 people or 6 people. And Nan and Jay will go through each table and give some advice or thoughts. So maybe you can have Kevin first here.
I'm Kevin, and I'm working on a project called ETHTaipei at ESC. The project is simply about how.
Do you need a microphone?
No, it's fine. It's fine.
Perfect.
Yeah, I'm working on ETHTaipei, which is a platform that allows data providers to share the statistic insight to the users. So user can define their application and send it to the data providers and ask for some statistic results like mean, median, and others, and without sacrificing the data privacy. Yeah, and we're moving on supporting MPC as the next step, and maybe FHE as a next as well. So yeah, and we can discuss more later. And if you want to talk in Chinese or Mandarin, you can join as well. I mean, yeah.
Okay, thank you. Thanks, Kevin.
Hi, I'm Vivian. I'm also from PSE team, and previously my project is more ZK focused. It's called URAP. It's a replication protocol, and now I'm working on mobile proving system, which is also right now it's more ZK focused. But I have some understanding about MPC and FHE. So if you want to discuss about the application about MPC or FHE, or you're thinking about if in case not enough for your application, you can so talk to me. Yeah, but if you need deeper explanation of MPC or FHE, you can just ask Jay and thank you.
Thank you.